Well, good morning, and welcome to the second OpenDev event that we are throwing. How many of you were at OpenDev last September in San Francisco? Okay, cool. Well, that's awesome. So we've got a lot of new people here. The concept behind OpenDev is getting together people across a number of different open source technologies and communities to focus in on a specific problem, and then try to think about how do we implement open source technology stacks to go solve that. And so the first time around in September, we focused on edge computing and what kinds of things we should think about in open source communities in order to meet the needs of edge computing and especially edge clouds. This time around, as I think most of you know, we are focusing in on CI/CD as our topic area. And the OpenDev event is it's less meant to be kind of a traditional conference, and it's more meant to be a working event where we get together people with experience from the development side, from the engineering side, from the business side, and talk about these problems and what we need to do from the technology perspective, but also from a culture and knowledge perspective. So these events are something new that we've been trying within the OpenStack Foundation, and the first one went really well. I've got a lot of anticipation for this one as well. So this event is the only thing that's up here on the third floor. This is kind of the main presentation room, and there will be presentations running in here today and tomorrow. Behind us, kind of along this wall, where all of the window space is, there are 3 rooms that are set up for the collaboration and training areas. And the collaboration sessions are really meant to be very open-ended. Each session has a moderator. The moderator is not there to kind of present and talk to you. The moderator is there to lead a discussion around a topic. And collectively, everybody can contribute to that. We take notes. After the event, we go through, we kind of collect all of the notes, think what the learnings are, what the tasks are, what do we need to go do in different projects to improve it, and hopefully we can kind of move the state of CI/CD forward. To help us organize all of this, we had a programming committee that represented a number of different communities and companies and people with a lot of experience in the CI/CD space. And we'll be hearing from almost all of them this week. They'll be either presenting this morning or throughout the week or leading different sessions, and an opportunity to really get their heads into whatever your problems may be as you are trying to implement and approach CI/CD. But ultimately, like I said, this is really about collaboration and working together to learn from each other and improve what we think of as the state of the art in CI/CD. So to kick things off, I just wanted to quickly run through a couple of thoughts that I had about why I think continuous integration, testing, delivery is really important as a discipline and something that's worth all of our time. If you think about kind of how humans move forward throughout history, generally it coincides with the pace of technological progress. But for most of human history, technological progress has been tied to hardware. Whatever you're thinking about in terms of communication or finance, it's always been hardware-based for thousands and thousands of years. And even in kind of the computer age, up until very recently, things were very hardware-focused. And that was what kind of determined our pace of being able to make progress. Of course, I think we are all in the software industry in some way and are very familiar with the concept that Mark Andreessen phrased as software is eating the world. And when we look at all of these areas now, science, finance, communication, travel, technology, and specifically software plays a massive part in all of it. And so in some way, the pace of progress is connected to the pace of software development and the pace of software progress. When we talk about software, we talk about deliveries. And I was thinking, the thing that I think is really interesting to see as a trend is how delivery timescales are changing. And if you think about deliveries in our life. There are all kinds of deliveries that we might experience in our lifetime. We might have kids. That's a delivery that happens a few times in our life. Birthdays. Those are, we might get gifts that get delivered once a year. Packages from Amazon, weekly. Bills on a daily basis. Emails that get delivered. I get emails every minute or more. That's a delivery that I would like to see slowed down. But as we think about these different timescales, I think that what we've seen is software also used to be delivered in a very similar way. Software used to be released on multi-year cycles. And then it was, OK, let's see if we can get a release out every year. Let's see if we can do it on a monthly basis. Let's see if we can push code every week. And I think that the goal of CI/CD is ultimately to get software delivery to kind of that email delivery timescale, where as software changes are happening, they are being delivered continuously to our users, to our company, and that means that all of this is moving forward more quickly, and our organizations are able to get more done. But this, is a huge, huge change for our craft, and it's one that I think I know I'm a technologist, and so a lot of times the first thing that I think of when I think of a problem is what technology should I use? And I think we're going to talk a lot about that in this event over the next couple of days. But it also is a huge culture problem. It's something that requires you to not just implement technology, but also transform the way that we think about how do we work in our businesses, how do we collaborate with each other, how do we approve things, all of these simple things. And so to me, that's something else that I hope we can really dig into over the next 2 days as well. And so just the thought that I want to leave you with as we get the event kicked off is, in the audience today, we have a lot of people who have a lot of different experiences, and we all have things that we can learn from each other, whether those are success stories or stories of failure. This is a great opportunity, and if we get it right, and if we figure out how to really implement CI/CD properly, then we're not only talking about writing and releasing software faster, but we're also talking about how we can make technical progress happen faster and move humanity forward faster. So I think that's an awesome mission for all of us. So that's all I'm going to say. I'm going to turn it over to some of the real experts now to take us through the rest of the keynotes. And to get us started, I want to invite up Fatih Değirmenci and Daniel Farrell. So Fatih and Daniel.
Hello, I'm Daniel Farrell from OpenDaylight.
And Fatih Değirmenci from OPNFV community. Good morning, everyone. Thank you for the interest you are showing here, because the area we are talking about this morning or during this week, continuous integration and continuous delivery, is a really crucial area for us, for all of us to be successful in open source communities. During this upcoming 10 minutes, we will talk about our experiences when it comes to how we solved some of the common challenges we have in continuous integration and continuous delivery area from our community's perspectives. And those things really applicable to any open source community out there trying to build the software, test that, integrate that, and make available to end users. So as I mentioned, I am from OPNFV community. And I'm not sure how many of you know what OpenDev stands for. It's basically Open Platform for Network Functions Virtualization. It's an open source project which was established about 3.5 years ago to realize HC NFV architecture and implement this next generation telecom network infrastructure using open source technologies such as cloud, virtualization, and so on. And as we all know, the networks today, they are built using proprietary hardware and software, and really the open source is changing how things are done. And in order to see how viable or how good those open source technologies are, the OpenDev project was established. And OpenDev is kind of a unique project. If you look at OpenStack or OpenDaylight, those open source projects generally develop certain technologies, and they do continuous integration as part of their workflows, and they provide fast feedback to their developers and their users. And these communities generally work pretty close to SCM, Git, Gerrit systems, and their target is mainly their developers. And OpenDev was established to fill this gap to ensure that the components or technologies developed by these open source communities are put together, tested together as a system, and find out if there's any missing feature, functionality there, or if there are any bugs there. And so OpenDev, in summary, is a system integration and testing project done as open community. And how we do that? We basically, the telecom networks or NFV stuff is, when we first started, we initially started with OpenStack as our virtual infrastructure manager. And then we took OpenStack, for example, and then we tested OpenStack as it is using Neutron and default networking options. And over time, we moved towards the SDN area, and we started working with Open Daylight community. And this time, instead of using Neutron, we replaced the Neutron backend and put Open Daylight there. And this time, we tested this combination. And this was our first release about 3 years ago. And we basically released the integrated OpenStack and Open Daylight platform to our end users. And we basically started talking to and working together with these communities to ensure that whatever we found there as missing or problematic, they get fixed directly in upstream. So OpenDev doesn't do development in its own community, but it works upstream. So it's our motto, upstream first. And we go and fix those things there. And this basically means that continuous integration is crucial for OpenDev community, like other communities. Since we are an integration project, we have to ensure that we automate these things and we iterate much faster, we test things much faster, and we provide feedback much faster. And over time, we increased the number of combinations we support. And as part of our release, we had more than 50 different combinations. And some of the projects we are working with, you can see on this diagram, we have more than these components. I think we work with more than 10 different communities, and we bring all these different components together, we test them, and we see if they work, and we provide feedback. But over time, we realized that this is very slow. And we made our calculation. It took at least 6 months to provide feedback to upstream communities, which is basically not continuous integration. The reason for this was we were using stable releases of upstream components. And then we started thinking about how we can solve this. And Open Daylight was the first community we started working with. We asked Daniel and other nice guys from Open Daylight community to help us with this, shared our problems, concerns, and then we got their help.
Yep. So when OpenDev was born, we were a little bit older. We'd had a little bit more time to kind of mature as a project, learning a lot of lessons from OpenStack, copying a lot of your infrastructure. So we had the position where we were able to see these new challenges coming and prepare ourselves for them. Again, OpenDev, to rehash, is trying to do continuous integration on delivered open source projects like Open Daylight's, not sort of internal unit test level CI or whatever, but our full thing that we're shipping out to customers and users and standing up in complicated deployments. OpenDev wants to take that and do CI on that. And this was a strange situation, right? We needed to prepare ourselves as a community, as a set of communities for working in this integration. We started to see these questions come in from developers in both of our communities. For example, I could be an OpenDev developer and be trying to set up one of these deployments with a SDN controller using Open Daylight as the backend or something, and running into some bug, and I'm talking to my Open Daylight friends, and they say, oh yeah, we know about that one. That was fixed last week. Great. No problem. And then OpenDev developers, okay, so we can get that into one of our releases to use in our ecosystem in 6 months or a year, depending on your release schedule. And we're going to be blocked on stuff until then. Obviously not a good answer, right? Or we would want developers working together to test solutions that they're collaboratively building and testing, building an Open Daylight, testing an OpenDev, and to get that quick feedback cycle that developers are used to. We have these same types of problems. We would end up having Open Daylight developers see the value in these big labs that OpenDev can stand up using real installers. So we're using DevStack or something in our CI because it's quick and easy to work with, but OpenDev is using proper OpenStack installers, using virtual and bare metal deploys, the kind of infrastructure that we really care about and would like more access to. So we had Open Daylight developers working on bugs with that great infrastructure, but they want to test from latest master, not sort of our 6 month ago release version. We ran into this class of problems and realized that we needed to build continuous delivery pipelines. That for a project like OpenDev that does CI on released artifacts, it's kind of a fact of nature that the integrated projects have to provide continuous delivery pipelines into such a project. So for OpenDev to really do CI, for it to not just do testing on previously released artifacts, but continuously test, continuously integrate the projects that it's consuming, the consumed projects have to provide continuous delivery pipelines. So this is our big lesson. So as we started implementing this, we, I think, followed a path that probably many of you have followed different iterations of. There's no magic about this particular one, but we'll talk about it briefly. We started encountering many different types of users, right? So we had people who wanted to deploy against CentOS or Ubuntu or SUSE. They needed their own specific type of packaging logic to lay down OpenDaylight on the file system. We realized that just laying down OpenDaylight on the file system was totally insufficient, that we needed to have all kinds of configuration knobs for setting up HA deployments, and in your weird particular environment, we need to tweak IP addresses in a certain way or something, right? So these are configuration knobs. These aren't sort of OpenDaylight internal logic. These are how we do integration deploy work that OpenDev is doing a great job of validating. How we do that type of logic and test that and do it in repeatable ways that are owned by the projects themselves and not owned by OpenDev. So another lesson we learned is that the configuration management logic is too complicated for OpenDev, the integrator, to really know for all of that huge diagram of projects that are being integrated. Each of those projects needs to be responsible for knowing their configuration knobs and providing easy tools for the consumer OpenDev to work with. So we started building configuration management tooling. Puppet was kind of the norm, the only major option at the time, so we started there, and we've since added Ansible support. We also, of course, try to ship things that are nice for users, that aren't just such big, complicated tools for big, complicated projects like OpenDev. So we can reuse some of these abstractions, so we can build on our packaging logic, build on our configuration management logic, and then basically for free get things like containers or VMs that users can just run Docker run -it OpenDaylight/ODL, and then have a craft shell and poke around a bit, not maybe able to do as complicated things as they would be able to do in a full triple deployment or something, but get their feet wet.
Yeah. So this is all real. We are not just sharing our dreams with you. And this resulted us to create a new initiative together with OpenDaylight and other communities we are working with, which is called OpenDev Cross Community CI, XCI. And with the help of our friends from OpenDaylight community and from OpenStack community, we are now able to deploy OpenStack from trunk, OpenDaylight from trunk, and we are expanding our scope and we already start talking to all these different communities, such as ONAP community, which is very important in telco world, and we need to ensure that we can deploy ONAP from trunk as well. And we are working with CNCF community, and we are bringing Kubernetes. And what this will result in is that, as I mentioned, like our previous way of working gave us, our developers and upstream communities, feedback in 6 to 13 months. Now we can reduce that feedback to weeks, and we can reduce that feedback time to days. Currently, we are on week times, like we can deploy OpenStack and OpenDaylight together from master on a weekly basis, but we want to push that even further and do that on a daily basis. And what is even more interesting is that we want to do that per patch basis. And we have plans to look at Zool to ensure that we enable this cross-project, cross-repo type of dependency and dependent pipelines to ensure that whoever does a development in OpenStack, if that patch depends on OpenDaylight, we should be able to put that combination together on our labs and give feedback based on that combined scenario rather than standalone. So in summary, I think we had lots of advancements in this area, and we have been working together pretty closely, not just with OpenDaylight or OpenStack, but with 8 other communities. And this resulted in a creation of this OpenCI initiative, which we came together end of March, and we start talking about these things as a whole, like a big family. And we understood that this is a problem we have to solve, and we can't solve this as small or standalone communities. OpenStack is great, but we need to work together to ensure that we have all this experience put together, and we work on these things together to make things even faster, make things even better, and make things even easier for our users. So if you are interested in these things, just join us and then help move things forward much faster than before. Thank you.
All right, thank you, Fatih and Daniel. And there are, if you look on your schedule for OpenDev, or if you go to opendevconf.com and look at the schedule there, you'll see a number of OpenCI related sessions. All right, so next up we have a presentation from Boris Rensky from Mirantis. And I need the other screen to be able to start this one up. Come on, Boris, we'll get you set up here in a second. All right. Welcome. Take it away.
Thank you. Where do I progress the presentation forward?
On the keyboard.
Oh, OK. High tech. This keyboard, yeah? OK. All right. So good morning, everyone. I got my backpack stolen from my car over the weekend, so I'm now carrying my backpack like an idiot with me, like a child everywhere. I used to throw it everywhere. All right. So the title of the talk is why OpenStack folks should care about Spinnaker. But the overall theme is a little bit broader. And the theme is basically about the importance of various open source communities that are out there working on infrastructure projects, working more collaboratively with the communities that are there, working on different app tools. And in my personal belief is that this area where these two communities intersect, where the app people and the infrastructure people intersect, if we could get that part right, if we could get that collaboration right, this is what's going to unlock an order of magnitude type returns with respect to open source innovation. So I'd like to open with this. There is arguably a notion out there that the application folks and the infrastructure folks are already working very well together. After all, we have Cloud Foundry in kind of sponsoring and exhibiting in OpenStack, OpenStack exhibiting in KubeCon, all this kind of collaborative SIGs going on. But my personal observation has been different. My personal observation has been that in reality, generally, these two communities don't understand each other very well. I can share some kind of anecdotal observations. So when it comes to Spinnaker at Mirantis, we first encountered Spinnaker like a few years back. We weren't even looking anywhere in the application direction. We were deep infrastructure, OpenStack guys at the time. And one of our customers said, we don't really want to use Horizon. We'll just use OpenStack API. Instead of Horizon, we want to do this thing called Spinnaker. And our guys just went ahead and kind of did it. I probed with the team and asked, you guys want to take a look at why does it make sense maybe? Is it interesting? He said, no, it's Spinnaker is just some sort of CI/CD thing. It's like the app thing. Like, we don't care about this. We do OpenStack. Then, as we started eyeing the space a little bit closer, we started talking to our customers, and we probably spoke to 40 or so customers, primarily OpenStack customers, because that's what our customer base is, about CI/CD space and Spinnaker in general. And most of the answers we got is like that it's very similar to what we heard from our internal dev teams 2 years ago. Like, we care about infrastructure. We don't understand CI/CD. And also notably, just recently, I've been browsing through the OpenStack user survey. And I've noticed that up until recently, we've kind of had a section there that covered types of workloads and types of applications that run on OpenStack. But in the most recent edition, I didn't really find anything about that. which I don't think that maybe Foundation doesn't care about that. I think that maybe the users that are running OpenStack, at least that's what we're seeing from our experience, don't really care about the apps up above. So the reason why I picked this picture is not just because it's kind of memorable and funny, but because I think it also actually represents the root of the problem fairly well, in my view. The infrastructure folks, which is us, Mirantis, OpenStack folks, have a particular view of the application space in general. And they view the application space kind of looking up at the application from the infrastructure. Whereas the application guys are looking down at the infrastructure from the application. And those two vantage points are actually very different. And I wanted to dive into a little bit and show a little bit more as to what I mean by that. So this is pretty common type of DevOps dilemma story, where today, if you talk to most CIOs in an enterprise, they'll all tell you, yes, we are doing digital transformation, releasing software faster is the most important thing for us. But if you start digging into how the organizations are structured and how the different teams are goaled and what their KPIs are, the apps people and the infra and ops people are very different. Starting with the fact that all of the people that are building applications in the enterprise are typically reporting into line of business. There is many of them, and they're distributed. If you look at the ops and infrastructure people, it's a centralized function reporting into the CIO. Of course, app people want to release faster. Infra people want to maintain the uptime SLA and control cost, and as a derivative of that, avoid lock-in, because lock-in usually translates to cost. And finally, and probably most importantly, if you're an app guy looking down infrastructure, you want to use whatever tools and frameworks you like, and you just don't want to worry about the infrastructure. If you're an infrastructure guy looking up at the applications, you want everybody to use your infrastructure. And if you go to any enterprise, like the folks that are implementing OpenStack internally, like they're literally goaled on having people use their infrastructure. So they're looking at the world through that prism. Another interesting kind of a disparity between the app world and the infrastructure world that I've observed is kind of what framework is used to look at the space and to look at the problems around the space. So at the infrastructure level, we look at the space in terms of stacks. So we have hardware, then we have our virtualization layer, then we have our OpenStack or orchestration API, and then a PaaS. And the kind of movement there is we want to move up the stack, and this is kind of where innovation is happening. In the app world, people think primarily in terms of pipelines. And the trend there is to actually do as much as possible at the early stages of the pipeline, at like the build stage. And the move up the stack in the app world is called shift left. And you can Google shift left, and you can find a bunch of stuff about what that means. It's kind of like a trend, right? So this combination of kind of vertical stack mentality among the infrastructure people and the need to get everybody to use their infrastructure usually leads to somewhat imperfect solutions by the infrastructure people to the problem of the application developers, which is to release faster and more often. And the two solutions that we saw so far is kind of PaaS and CMP, right? So PaaS is kind of a, how do I get a developer to use my infrastructure and give them the higher level services that will help them build faster. So, and we know that the first iteration of PaaS, which was largely about kind of producing a service catalog, didn't really work out very well. Like .cloud ultimately evolved and became Docker, and the whole PaaS is now kind of disaggregating and what we're referring as CaaS. CMP is a slightly different cloud management platform, if some of you are not familiar. It's kind of a similar concept, but different slice. It's, again, kind of an infrastructure personal solution to the developer problem of, I want to use different tools and I want to use different type of infrastructure. So, OK, you can do it as long as you go through some sort of API that I control. And this way, I kind of mitigate login. So now, this is kind of the end of the section about the differences between the app people and the infrastructure people. Switching gears a little bit, this is like a slide from the Mirantis presentation that we've used for a long time to pitch OpenStack to a kind of higher level decision maker. And the summary is, buy OpenStack, you'll be able to build software faster. Part of me always understood why this kind of approach is important, because the message of, hey, buy OpenStack, it's cheaper than VMware, is not very inspiring. You have to give like a forward-looking message. The other part of me always kind of questioned how you connect the dots there. Like, OK, OpenStack is great. You have cloud. You can get VMs faster now and containers faster. But how does it connect to the developer releasing software faster? So as we started probing into what should we as a company do in the application space, we decided that we want to kind of start from scratch. And we want to forget about the fact that 95% of our business is OpenStack infrastructure. And we want to put ourselves in a developer's shoes. And we want to see how is it that we can actually help developer truly release faster. So we started unpacking the space. And of course, the first thing that we've come up against is this picture. We realized that this CI/CD thing that we initially thought Spinnaker and the developer people are doing is not just a thing, but it's actually two things. And CI and CD are two different disciplines. CI primarily has to do with taking the code and building some sort of deployable artifact, be it an AMI or a container, whereas CD has to do with actually taking that artifact and deploying it to an infrastructure target. Also, CI is a very developer-specific thing, typically attached to a developer team, whereas CD, similar to the infrastructure space in general, is actually usually a centralized function that requires orchestration of multiple roles and multiple tools. Very quickly, as we've kind of carved CD out into a separate thing and understood it, we realized that OpenStack all of a sudden is not just this cool thing that lets you get VMs faster, that it actually becomes an enabler for a much better pattern for lifecycling an application, which is the immutable infrastructure pattern. So I won't go into the details of immutable infrastructure. Most of you guys probably have heard of it. But the general idea is that you keep your configuration and keep your basically image consistent from dev to stage to production. And instead of fussing with making the best Puppet script that you can actually upgrade or change a VM in place, you just get a new VM and you spend your effort on building a deployment strategy or delivery strategy where you switch one VM for the other. And it's only possible if you have an API-driven infrastructure powered by OpenStack. So that immediately already made our story about we help you build and release applications faster much more convincing. And then taking this a little bit further, we tried to think about, is there a way to actually unify the concept of pipelines and stacks? And as we started looking at the space from kind of the developer standpoint, from the application looking down infrastructure, we realized it's not that hard. And you can think about the entire process as kind of one big flow. So you start with CI, where development teams build the deployment artifacts. Then you have your continuous delivery, which is responsible for orchestrating the many tools involved in deployment. Then you need something to actually orchestrate the virtualization layer underneath. And OpenStack does that, and it's kind of downstream from deployment. And then finally, you have your vert layer that is orchestrating the hardware. And if you zoom in on actually what OpenStack does and what Spinnaker does in this now unified flow, the roles are very similar. So if you think about why OpenStack became popular because enterprises had already invested in fairly diverse infrastructure such as storage, network, different hypervisors, et cetera. All of these things needed to be orchestrated together for you to be able to bring up VM, wire up the network, connect storage to it. And all of these orchestration tasks is what basically OpenStack did through its architecture that is built around pluggability. And this has been my historic pitch of OpenStack, right? So you can build a cloud based on your existing infrastructure investment. Now, when it comes to actually deployment and delivery, the task is very similar. It's just that the tools are different. So Spinnaker, just like OpenStack, its core tenet is pluggability. If you look at any enterprise, there is a vast diversity of different tools that are used in the deployment process. Different teams could be using different CI servers. You have your different SecOps and compliance teams that are using different artifact scanners, et cetera. You can have different tools for actually building the images. All of these things need to be orchestrated and glued together with an API. And the notion of actually being able to do it in a uniform way is exactly why Spinnaker was built. So connecting these things together, what comes to my mind is that if we as OpenStack people are agreeing that we should be looking somewhere up the stack and this is where the innovation is, the natural extension for us to move up the stack is not PaaS, but really the continuous delivery space. And Spinnaker to CD is what OpenStack is to basically infrastructure orchestration. And the reason why this is all important to all of the OpenStack people, I think, is because if you look during the last 10 years, the trend for infrastructure and platform services team, and this is the last slide, has been to kind of gradually progress from 10 years ago, focusing a lot on just actually physically wiring the infrastructure and doing infrastructure maintenance, to then in the cloud age, almost becoming an internal cloud provider to the your enterprise consumers, and building OpenStack clouds and whatever other clouds you do. As we progress forward, the role moves away from actually fussing with the infrastructure layer, which becomes more and more mature and more automated, and towards helping the developers actually deliver and deploy their apps faster. And I think that the core to OpenStack as a community evolving forward is actually embracing this vision and moving in that direction. So that's all I had. Thank you.
I was really curious to see if you were going to remember your backpack after you hid it behind the stage. Thank you, Boris. So next up, we have a talk on containers and microservices in a CI/CD world. It's going to be brought to us by somebody who's got a lot of experience with all of those, Elizabeth K. Joseph.
OK. So by way of a bit of introduction, before working on containers, I spent about 4 years working on the OpenStack infrastructure team. In that role, one of the things I worked on was trying to get some of our stuff into containers. But we're talking like 4 years ago at this time. To be honest, the container ecosystem wasn't really ready. We evaluated some stuff, and we realized we had to build so much around the containers that the tests we were doing weren't really going to be reflective of what we were building and testing and deploying. So I wanted to come back and say that 4 or 5 years later, containers are in a much better space now. And there's this really big ecosystem around doing CI/CD. So as a baseline, the idea is that you run everything in containers. So your Jenkins and your GitLab and your Spinnaker, and then all of your testing as well. And they can be lots of different size containers. And then you organize everything super efficiently. So everything has its place. And so in a data center model, you have this typical data center where the utilization is something like 12 to 15% for bare metal, 30% for VMs. And when you can use containers, you can put a bunch of these different services on a single server. So you have better resource utilization. And to show you sort of an example of how this all goes together, Kubernetes can totally be used. I happen to work on Apache Mesos and DCOS, so I'm going to show you a demo with that. But the idea is that you put it on any infrastructure. So you install your cluster, something like Apache Mesos or Kubernetes. You can install on top of OpenStack or Amazon or Google or whatever cloud, or you can just install it directly on bare metal. And then you install your orchestration layer on top of that. And then all of your CI/CD services go on top of that, in addition to all the tests that you're running. So we got live demo time. This is totally going to work. All right, so this is like a web UI for Apache Mesos. It's called DCOS. It also does a lot of other things, like networking and stuff between the containers, which was one of the things that I found was a problem about 4 years ago, but has been worked on by the Kubernetes team and the Apache Mesos team and a lot of organizations out there, Docker. So what we're going to do is we're first going to launch Jenkins. What I'm going to show you here is, hopefully in under 10 minutes, deploying a website with tests. So we're going to start off by installing Jenkins. And you can do a pretty basic proof of concept Jenkins install with a few clicks. So I have a cheat sheet over here. I'm going to actually pin this to a host name. In production, you would typically just mount a volume from some sort of shared volume. But since this is a demo, I'm just going to put it on the host, and that'll be fine. So that's Jenkins. And then we're also going to use GitLab. So everything in this demo is fully open source. And the demo itself, I put up on GitHub, so you can play with it later. GitLab. So we're going to make a couple of changes here. We're going to set the URL. I set up a DNS name for this earlier, CD. And then where's the next one? I'm gonna pin this to one of the nodes as well. So I'm gonna go ahead and run GitLab. Go back to my services. All right. Of course, these are gonna take way longer than normal because I'm on stage. So these are deploying. So what's happening now is Jenkins and GitLab are being deployed into containers. And then that should be up soon. All right, so Jenkins is up and running. Go Jenkins. Yeah, okay. And GitLab is still deploying. So the only thing I did before this demo to prep things was I set up the Mesos cluster, and then I allowed the Docker agent inside of the Mesos cluster to accept insecure registries, because there was no way I was going to set up SSL certificates on stage. Okay, so what we want to do, I actually have to make a change in Jenkins itself, because I also need to tell Jenkins that it has to run with insecure registries. So where's the configure system? Conference internet. All right. So I have to really dig into the configuration here in Jenkins to set this up. All right. Okay, so Jenkins is all ready to run things without SSL certificates. So if anyone's like logging into this URL right now, I'm in big trouble. So come on, GitLab, what are you doing? All right. Alrighty, so. I'm just gonna set up this brand new GitLab. I'm gonna run everything as the root user in GitLab because it's a demo. Don't do this. All right, so GitLab, it's pretty empty right now. So what I'm gonna do is I'm gonna create a new project. So I'm gonna call this site test, and I'm gonna make this a public project. I'm not gonna put anything in it for now. All right, so we can see that this is empty. So what I'm gonna do is go over to my terminal here, and I'm going to clone it. And yes, it's an empty repository, so I'm gonna cd into it. And then I have some files prepared, so I'm just gonna copy those over. Oh. All right, so we've got a Docker file, an index.html, which is the site that I'm actually going to launch, a Jenkins file, and a Marathon file. Marathon is the schedule inside of that runs on top of Mesos. So I'm just going to add all this stuff. I'm just going to git push it back up. All right. So that's sending the repository up to GitLab. And now the repository is not empty. Hooray, okay. So while I'm here, I'm also gonna show you that we also have this registry. So this is a Docker image registry. It is currently empty because I just created this thing. So we've got our repository set up. So I'm gonna go back over to Jenkins. I'm gonna create a new item. I'm gonna create a pipeline, and I'm gonna call it site test. How are we doing on time? Oh, okay. All right, so where is this? I'm gonna pull this from an SCM git. Actually, I missed a part here. I have to look at my notes. So the section I want here is the build triggers, right? So I'm going to pull SCM. I'm going to do this every minute, and then Jenkins is going to be really grumpy at me. Yes, I want to do it every minute. So grab the repository URL, which I can grab back over here. I need to add some credentials. So this is so I can actually push things back. And this is called GitLab. Okay, so we're using those credentials. We have a repository, and now we're just going to save that in Jenkins. And since this repository already has a Jenkins file inside of it, it's going to automatically find that that has a Jenkins file and start the build. It should start within a minute, so we'll see how this goes. Come on, Jenkins. Well, that's working. I can actually show you the Jenkins file. So I mentioned everything here is running in containers. So it's a pretty simple Jenkins file. Yeah, it's less than 60 lines. And it's actually just a series of Docker commands, essentially. So it grabs the credentials from GitLab, and it pushes an image and everything. All right, so we actually have our job running now. That's exciting. All right, let's see what it's doing here. I'll make this a little bigger here. All right, so what it's doing now is it's going out to the Mesos cluster and just finding a place to run all of these Docker commands that I told it to run. So I didn't have to set up an external cluster. It's using the same one that GitLab and Jenkins is running on. You might not want to do that, but the idea is that it actually reaches out using a Jenkins Mesos plugin. There's also a Jenkins Kubernetes plugin, and I think there's also one for Docker Swarm. So again, like, it doesn't matter what platform you're using, really, but I happen to work on this one. So it got stuck here once when I was doing this demo. Yay! All right, so it's checking out the code repository. And actually, I can go back here, and we can see our little stage view here. In a perfect world, this would be like 5 checkboxes of green really soon. All right, so it was able to check out the code repository that I gave it. It's now building the Docker image. And then once it builds the Docker image, it's going to push that up to GitLab into the repository. The registry that I showed was empty. So it has to like download the Nginx image that it's trying to run on. Go back and see. Running all kinds of stuff. All right, so it's now publishing the image to the registry. And once that's done, I can come back over here. All right, so it created the directory. It doesn't have an image yet. It's uploading it. Almost done. All right, so I'll look back here. All right, I've got a Docker image in my registry. That's really good. And then it actually deployed the system. So if I go back to my DCOS UI here, I now see a site test thing here, and this is the website deployed. Ah! Oh, don't do this to me. Okay, that's just sad. Wait, why is it linking to GitLab? I know what I need to do. Hey, there we go. Okay, so the site is up now. All right. I'm out of time, but I just want to show you if I just say, all right, so I just want to show you that it's going to kick up another pipeline. But that might, oh yeah, so there it goes. So I just pushed another commit to Git, and it's just going to run through this all again, and then we'll see a new website being deployed. The test that it did, it just did a link checker against it. So it just looked at, it ran some Docker commands to just make sure all the links were working on the website. So yeah, that's your demo. Thanks.
Awesome. Well, thank you for doing the demo and being brave enough to start all the way at creating your own Git repository. That's the earliest I think I've seen a demo start in a while. Cool. So up next, we will be hearing about, we've heard about Spinnaker, we had Jenkins, and if you were around yesterday at the kickoff of the OpenStack Summit, you might have seen that we launched Zuul v3 and kind of announced that as an official project. And to tell us more about that, we have James Blair from the Zuul project.
Thank you, and good morning. As Jonathan said, we talked about Zuul as a new top-level project under the OpenStack Foundation yesterday at the OpenStack Summit Keynotes. You might have seen that if you were there. If you weren't, that's OK, because you're all caught up now. But despite the fact that it's a new project under the OpenStack Foundation umbrella, it's not a new project overall. So the timing of this is interesting. Why are we hearing about it now? The answer is that we released a new version called Zuul v3. And when we were developing v3, we had a focus on making sure that Zuul was usable by users outside of the OpenStack project. And that's because Zuul enables a method of collaboration within and across projects, which we think is pretty revolutionary. And we wanted to share it with people. So what's so revolutionary about Zuul? Zuul is focused on the future. We've come a long way with CI systems over the years. The earliest systems are what I would call post-merge systems, where when a developer writes a change and pushes it up to a repository, the CI system runs on that change, or maybe it runs periodically, every hour, that sort of thing, maybe every minute. But the thing is that a post-merge system can only tell you that something has gone wrong. It tells you that you've screwed up and you have to spend the rest of your day trying to figure out what went wrong and fix it. Fortunately, attitudes have started to change with the rise of code review systems. If, say, you go to GitHub now and open up a pull request on a project, it's very likely that some CI system is going to run tests on your change. And it's going to say that this change is red or green. It's OK to merge or not OK to merge. And that's great. That's a big improvement. I think that that's focused on the present, though. It's just one change at a time. What are you going to do with this single change? With Zool and its process of gating, it's focused on the future. And the way it does that is it looks at a proposed change, and it looks at all of the dependencies of that change. And it looks at all of the changes that are scheduled to be merged ahead of that change. And it says with certainty that when all of those changes land, the build is still going to be green. So Zool is, again, focused on the future, and it lets developers do the same. So how do we get from pre-merge checks to gating? And this is because of the way Zool was developed for the OpenStack project. In OpenStack, projects are highly dependent on each other. We wanted to make sure that a change to one project didn't break the other projects in OpenStack. So we developed Zool so that before merging a change, it pulls all of the projects together and tests those at once. So Zool, when it pulls those changes together, when it pulls those projects together for a change, it also pulls in all of the changes that it knows are going to be merged in all of the other projects too. So in other words, Zool knows the future state of every repository in its system, and that's what it ends up testing. The key to all of this is the idea of dependencies. With dependencies as a first-class concept, that's a world of possibilities opens up. Not only can we avoid projects breaking each other, which was our original goal in developing Zool for OpenStack, but we enable developers to make structural changes across communities, and so that they can demonstrate that those changes are going to work together before changes land. This, I think, is the revolutionary thing about Zool. It's when you stop seeing your CI system as something that nags at you for having programmed wrong, and you start to see it as something that enables collaboration. And this is true even if your project is not set up like OpenStack. Even if your project is a monorepo, that still probably has dependencies on something, on external dependencies. Or if you're in a corporate environment where you have individual teams responsible for microservices, the same thing applies. So I want to walk through a quick example of how dependencies work and how you can create these series of changes that cross communities. So for this example, I'm going to talk about writing a change to sender that you want to expose all the way through to an end user in Kubernetes. So you'd start by writing a change to sender. Say what we're going to do is we're going to add a new option to sender to securely delete a volume when it's done. First you'd write your change to sender. This is not a real change, so don't go looking for this one. I only have about 3 minutes left, so I've had to simplify this a bit. But so you start by writing your change to sender, and you push it up to OpenStack's Garrett server. And then in order to be able to use that in Kubernetes, you need to write a change to Gopher Cloud. That's the Go language API, Go language library for interacting with the OpenStack API. So you'd write this change to Gopher Cloud that uses the new micro version that you presumably added to Cinder. And once that's out there, then finally you can write a change to Kubernetes to expose this option to end users. So with all of that done, you've got 3 changes out in the wild. But these are just 3 independent changes out there. Maybe you know they work together. Maybe you can promise all the developers that everything's going to work out when they land. Maybe you can try to convince them to download all of these changes and run them, and they'll see this working. But otherwise, you're just going to have to wait for the change in Cinder to land and for Cinder to make a release in order to see all of this in action, unless you use Zul's dependency feature. So to do that, you'd go back to your Kubernetes change, and you'd add a single line to the pull request description up there, where it says depends on, and then it has a URL to a GitHub pull request. That says that this change to Kubernetes depends on this other change to Gopher Cloud. And obviously, this is a human-readable thing. If you read that, you'd probably be able to figure out what it means. And if Zul sees that, it understands the same thing. It knows that whenever it does anything with this Kubernetes change, it needs to also include the change to Gopher Cloud. So then you go to the change to Gopher Cloud, and you do the same thing. You add a depends on here that says this depends on the change to Cinder. And you'll notice this time it's not depending on a GitHub URL, it's depending on a Gerrit URL, OpenStack's Gerrit. And that's fine. Zul understands both, and it'll pull those changes in from both of those systems. At this point, if you were to inspect Zul's memory, this is what you would find: 3 changes that are linked together. So Zul understands that dependency between them, and whenever it does any work with those changes, it integrates them all together. But let's say that's not enough. Let's say because you haven't, because this is a new feature, the Cinder developers perhaps want to see a brand new integration test that's actually exercising this end to end. We can do that pretty easily. We can add a new job to Zul's system. And so this is what Zul's configuration language looks like. It's YAML. It's, again, hopefully human readable as well as machine readable. And here we're just defining a new job, which we'll call Cinder Kubernetes Secure Delete. And then we're going to say, run this job on changes to the Cinder project. So we make that change to a file in the Cinder repository, and we push it up to OpenStack's Gerrit again. And we add one more depends on line to this change. We say that this depends on the Kubernetes change. So now, if you look at what Zul is doing, we've pushed up our new change to add the job at the bottom. And you can see that it's a change to Cinder, and it's running a job called Cinder Kubernetes Secure Delete. And that change depends on our change to Kubernetes, which depends on our change to Gopher Cloud, which depends on our change to Cinder. And what we're doing here is we've told Zul to create a new job and to run it, and as part of that job, pull in unmerged code from 3 other repositories. And none of these changes have merged yet, not even the change to add the new job to the system. So in this way, developers can, this is what I mean when I say we can test changes from end to end. One end is the beginning of the process where we add the original change to Cinder. The other end is all the way to integration testing. So we've seen this entire process work before we've landed a single change. If you'd like to see more about Zul, Monty Taylor is giving a talk later today on called Zul v3 for gating. And Paul and Mohammed are doing a workshop where they will help you install Zul and configure your first jobs. And at both of these talks, there will be Zul stickers. Thank you.
Testing the future is is a cool concept. It'd be cool if we could do that in our lives as well, in other areas. How late will I be up tonight? OK, so can we get the screen here for... We're done with Boris. All right, so next up, we're going to hear from one of the Spinnaker leads who works at Google, Stephen Kem.
Is this on? Yeah. There's been no shortage of tech press coverage, case studies, blogs about some huge success of moving to the cloud over the years. But I believe that public cloud adoption is only now reaching critical mass, where it's become to the point where it's interesting and impactful. And it's because that point is where not only the tech bleeding edge companies are able to adopt cloud, but so are the rest of the world, are able to go ahead and adopt cloud at scale and to impact. That $250 billion public cloud market by 2020 is not going to happen through just the Spotifys, the Netflixes, the Snapchats of the world. And we should stop pretending as if it will. Furthermore, the Spotifys, the Netflixes, the Snapchats, and the Googles for the matter, while we'll continue to invest in pushing that edge, at scale also want to hide the complexity toward stability and repeatability. My goal here is to set that expectation as we turn the corner in public cloud adoption, that cloud ecosystems have to work at scale for everyone. And until it does so, we'll never reach the world-changing success that it aspires to become. Neither of the computers are. Like, that's not my presentation either. In the meanwhile, another reality is that the cloud is changing too. We are increasingly moving toward something that's called cloud native, sometimes referred to as cloud v2. And infrastructure as a service offered us capabilities we didn't have before. But fundamentally, it was the same technology with a different operating cost model. Cloud native technologies like Kubernetes, for example, are aiming to take full advantage of the scale and the flexibility that cloud offers in a way that infrastructure as a service never could. But it brings with it a new order of complexity and a new ramp to productivity, and that trajectory will necessarily continue going upward. So what does that mean for developers? Do we need to all learn a new set of primitives, nuances around edge cases, better YAML templating systems? And I think the answer is hopefully not. You've all read a lot of blog posts out there, people sharing the systems that they put together in order to deploy to a system, whether it's Kubernetes or OpenStack or whatever it might be. And some of them are reasonable, and some of them are Rube Goldberg machines. I think we've written a couple ourselves as well on the Spinnaker team. And you might be feeling the pressure that you need to be able to do the same in order for you to not fall behind the curve. And I am openly reminding all of us to something we agreed on years ago, that developers should continue to focus on feature code that platforms should hide complexity, and that tools, not developers, should be solving domain-specific problems like CI and deployments. So let's take continuous delivery as an example. We say continuous delivery, its goal is to safely and frequently deploy changes to production. If you break down what a CD tool really needs to do well, it's actually really simple. It needs to help you manage the things that change so you can roll them out. It needs to give you visibility to the things that are changing and a way to validate that things are going well. And then third, when things go poorly, it needs to help you remediate when change goes badly. Now, I work on the Spinnaker team at Google, and Spinnaker is an open source project that we worked in collaboration with Netflix and many others. And we've worked hard to strike the right balance between exposing and surfacing the things that you want to manage in a very particular way, multi-regional rollouts, exponential rollouts, for example, promotion of code across environments, and black boxing the things that you shouldn't have to deal with and encapsulating those things. So a single confirmed deployment, for example, or more advanced things like automated canary analysis. And this is true for all the other platforms out there, including whether it's AWS or Mesosphere or Kubernetes or OpenStack. But let me walk through a couple of examples with Kubernetes on how we need to go and how there's complexity in doing these things well and how we need to go ahead and abstract that successfully. So for example, in Kubernetes, when you have a binary change, you have a new Docker container, typically here's how you do it. You build a Docker container, put a tag on it. You open your Kubernetes manifest, and you go and update that section that says what the image tag is, and then you go and deploy it out to Kubernetes. Now, Spinnaker, as well as many other systems, can automate that for you. They can go and react to events from pub/sub messages, go and retrieve artifacts from source repositories like GitHub, and then go to make the call to deploy that out to Kubernetes. But if you think about what needs to be done here, it's about taking the event message's context, the event context. So for example, that pub/sub message might specify the new tag that was built, and then translating that into pipeline-specific context, and then injecting that at runtime into the Kubernetes deployment itself. It's about getting away from wrangling that Kubernetes manifest file every single time something changes, because this is better than manually wrangling it, which is error-prone. And it's actually even better than scripts or systems that might update that manifest for you, but don't carry through the process of confirming that the deployment was successful and following through by automating the process when things go well and when things don't. Okay, another example, config change in Kubernetes. In Kubernetes, configurations are done via config maps. So every time you have a configuration change, so your application parameter, a database password changes for your application. By the way, how many people have worked with Kubernetes here? Okay, great. So about half. The key idea here is that there are implementation details that your developer shouldn't have to go and wrangle. And that effort should not scale linearly with the number of development teams, the number of rollouts that you do. It should scale sublinearly. And that's what the developer should continue to go and expect. So we can go ahead and talk about details later, but that's not really important. Because then the key is that as you do things like, need to handle things like rollbacks, the system can handle for you as well. So you do a deployment, v001, looks good. Binary change, v002, looks good. Config change, v003, something went wrong. And what a tool like Spinnaker and what tools should be able to do is to go to mark a point in time where you have a known good binary and configuration combination that you can go and roll back to instantly. Not look up lists that you maintain, not go through code repository, commit history to figure out which YAML combinations you have to wrangle together to get a combination done. That's a simple example of hiding the implementation details for you. And then when you don't focus on the implementation details and you focus on the domain-specific problems, we can tackle problems like canary analysis, so that when you go out and do rollouts, we're taking metrics and comparative approach to whether your applications are successfully rolling out or not. And there are many other things. And once again, the key point is, this is where you want the developers to interact with your systems, and not in the implementation details. So continuous delivery has a lot of momentum behind it. And if not done well, it passes on the burden and cost to the developers. And we think that there's a lot of work to be done here, but I hope you'll agree that this is good work to be done. So if you would like to join us, you can start by going to the website and checking out how you can get involved. And of course, throughout today and tomorrow, if you see me in the hallways, please don't be shy. Come by, say hello. I'd love to hear what you guys are working on and to share ideas. Thank you.
All right, thank you, Stephen. And there is a Spinnaker training session that's happening here as well. So we have one final keynote, and I think this is a keynote that probably a lot of us are going to be aligned with as open source developers and users. It's talking about how free software needs free tools. So please help me welcome Benjamin Mako-Hill.
All right. OK, so thank you for having me here. So I'm not someone with particularly deep experience in the kind of CI/CD tools that have been discussed by everybody else. I'm a computational social scientist, and I'm a teacher at the University of Washington. But as part of my work there, and as part of things that I've done for a while, I study and I build and I advocate for the provision of sort of public information goods, goods like, and in particular, sort of free and open source software and like free culture. And in that sense, I think that I do have a message that's relevant to this audience. What I hope to do today is to make an argument grounded in a little bit of this community is maybe like ancient history at this time, that free software needs to use free tools. I'm going to explain why I think that, and I'm going to try to explain how we can get there. So I've been participating in free and open source software for now more than 2 decades. This makes me feel old when I say that. And I want to begin with a story that might be familiar to some of you that have been around for a long time. But it's the story of BitKeeper and the Linux kernel. So BitKeeper is a revision control system. It was actually one of the first sort of distributed revision control systems, and it pioneered or was sort of made accessible a whole bunch of features that anybody who sort of develops software on the internet today, which is presumably most of you, will now take for granted. Things that allow people to work offline easily or maintain branches with low effort, merge changes in ways that took history into account. So on and so forth. BitKeeper was first released 18 years ago in this month, in May 2000, under a proprietary software license. It was developed by a guy named Larry McVoy and his company BitMover. Now, the BitMover business model was pretty typical. Basically, they sold licenses to use BitKeeper. McVoy was also a Linux kernel developer, and he wanted to help Linux, the Linux kernel project, and other similar free and open source software projects. So he made a special community version of BitKeeper that allowed hackers to use it without having to buy a license, but only for free software, only for open source software projects. Now, this free version came with a couple other asterisks, other than you can only use it for that. The community version communicated to servers that were run by BitMover so that the company could monitor what you were using it for. And so that, as a result, they could also sort of approve or disapprove what it was being used for. And the terms of service, that document that we all carefully read every time we use a piece of software, for both the community and the paid versions, barred users from participating in the development of any competing version control system. All right. So in circa 2002, the Linux kernel was still using CVS, the concurrent versioning system, which is a if you're fortunate enough to not be familiar with it, is an older version control system that was actually first released in 1990. And for a whole bunch of reasons that may be obvious to you if you are unfortunate enough to be familiar with CVS, it was really struggling under the weight of the project, organizationally and just in terms of the sheer size. And as a result, Linus Torvalds and a number of other sort of developers decided to move the development of Linux to BitKeeper. Now, a number of people expressed some pretty deep concerns about the move, despite the fact that they would all be able to get the community version in order to do their work without having to pay for it. One developer, Alan Cox, who at the time was one of the very most active kernel hackers, and actually maintaining large parts of the kernel, refused to use BitKeeper at all, and had to rely on a series of these gateways that people would set up, which would provide sort of one-way access to the code in BitKeeper. But Torvalds and other people thought that the benefits brought by BitKeeper basically were worth it. All right. So this is Andrew Tridgell. Tridge, as he's called, is sort of famous for a number of things, including being the developer of the rsync algorithm and being the person who helped create the Samba project, although those details aren't particularly important here. In 2005, so that is 3 years after Linux moved to BitKeeper, Tridge began developing an alternate client to BitKeeper, which he called Source Puller. And it basically was just, it would speak the BitKeeper protocol and allow you to get metadata on revisions. Now, Tridge had never agreed to the BitKeeper license. He just reverse engineered it. He actually just telnetted into the port and typed help, and it just explained the so it's like a pretty funny model of reverse engineering. But Tridge was employed at the time by the open source development labs, OSDL, an organization which is now kind of in some ways morphed into the Linux Foundation, which at the time was also employing Linus Torvalds and a whole bunch of other core contributors. Now, when Tridge did this, when he started this project to essentially build this client, Larry McVoy became incensed. And he announced that he couldn't take away Tridge's license because he didn't have one, but he announced that he was going to take away or withdrawing the licenses from anyone employed by OSDL, which included Linus Torvalds and many of the people that were maintaining core pieces of the kernel. Now, at this point, the community was relying pretty heavily on BitKeeper, and this was a big problem. Returning to CVS was not an option. So Torvalds and a bunch of the other kernel developers spent a whole bunch of time that they probably would have been spending working on Linux to instead build a new distributed revision control system that would help them do what BitKeeper did, but to do it using tools that were entirely free software and open source, and that as a result didn't make them subject to the whims of McVoy. And I'm sure you've heard of the system they created, because the system is Git. And it's featured in most of the talks we've seen today already. And it's something that I'm sure most of you use every day. It was after a period of pretty rapid deployment and in a pretty chunky state, adopted by the Linux kernel developers. And eventually, it was adopted by everyone else. So there's a happy ending to that story. But I think that despite that happy ending, it's important to realize that the events that I've described were deeply disruptive to the Linux kernel and to its development. And they were very costly. So I wish I could tell you that I thought that the free software and open source communities learned their lesson 13 years ago. And I think that the reason I'm standing here, have been invited to stand here now, is because in many ways we haven't. I don't think I need to explain to you what GitHub is, because it is also featured in most of the talks that we've seen so far, at least in one way or another. After the system is heavily integrated into, among many other places, a lot of the CI/CD tools and open development tools that people are talking about and going to be talking about today. And although GitHub began initially as just sort of a website to host Git repositories, and although some people still use it that way, it is now a large proprietary service which is used for tons of bug and issue tracking, branch management, managing pull requests, indirectly for a lot of the CI/CD stuff people are talking about, and much, much more. Today, contributing to a free and open source software project, more often than not, requires using GitHub. I talk to students at my university, technical students, and it's become clear in a couple situations that they thought that Git, the command Git, is just the interface you use to talk to GitHub. And I find this deeply ironic, because Git was created as a way of escaping the reliance of a proprietary software company running a centralized service. And in many ways, GitHub has created many of the problems that Git was created to solve. The parallels, I think, are actually kind of striking. GitHub, like BitKeeper, relies on a central server that allows a company, GitHub, to monitor users. GitHub, like BitKeeper, doesn't release its server-side source code or show us what's running on it, at least not most of it. And of course, despite being run by a for-profit company, GitHub, like BitKeeper, allows us all to use its tools at no cost as long as we're doing it to build free and open source software. And finally, GitHub, like BitKeeper, can turn any of us off without any warning, without any notice, and for any reason they want. And on this slide is just some text from their terms of service that I pulled this weekend that says exactly that. And I'm not trying to do GitHub scaremongering. I don't think this is because GitHub is horrible. I think this is actually pretty typical stuff. It's typical of the kind of arrangement with a proprietary vendor, which is helping support the development of free and open stuff. And I think that BitKeeper is a cautionary tale of why we shouldn't do this. So this isn't a talk about why you shouldn't use GitHub, or at least it's not only a talk about that. GitHub is just an example, one example of many proprietary systems and services that I could have talked about. And they're actually a pretty friendly one at that. And compared to many proprietary tools that live sort of within our tool chains, they're in some ways easier to move away from than many of the others. But I think it behooves us to learn from our mistakes in the past. And I can't help but think that our contemporary free and open source software world's continued reliance on proprietary tools and proprietary services suggests that we failed to learn from our experience with BitKeeper, with Linux and BitKeeper. So I want to talk about some of those lessons. The first lessons are that proprietary tools can help free and open source software development, and that the people trying to create them are in many cases just trying to help us. There are no villains in this story. There's not McVoy and not GitHub. The people building proprietary development tools and giving them away to all of us that are building the free and open stuff at no cost are trying to help, and they're very often valued members of our community. And what they're offering does, in many cases, help enormously. But despite wonderful intentions all around, the most important lessons is that it was a horrible idea for the Linux developers to rely on BitKeeper, and it ultimately burned them badly. The fundamental lesson, I think, is clear. When we're building free software or open source tools, we must reject proprietary software development tools. And I want to suggest that there are sort of two main reasons. The first is that not doing so makes us all hypocrites. We should, and I think that's important. It's important not just because we shouldn't be hypocrites, but it's important because not being a hypocrite helps us sell our stuff. We should listen to ourselves when we cite the openness of our software as reasons to choose our stuff over the proprietary alternatives. Openness and freedom means, for our users, that they don't need to worry about predatory vendor lock-in. It means that third parties don't get to snoop on their data. It means that they can join with other users to help find and fix bugs. It means that they can use their software for any reason, and they can never have that permission to do so pulled back if someone, including us, doesn't like what they're doing. Our reliance on non-free tools tells our potential users, software freedom is important for you as users, but not for us as developers. Using proprietary tools to develop free and open source software undermines the basic effectiveness of the strong ethical commitment at the heart of our movements and at the heart of our movement's success. So that's reason number one. The second reason is that the software we produce is only as free as the software it depends on for its continued use, deployment, distribution, and evolution. A free license and full access to source code means very little to a user who's attempting to modify that source code if they don't have access to the software which is required to make and then deploy that modification. It's not only developers' freedoms that's at stake, but eventually it's their users, all future downstream users, and so on. Those choosing to use non-free tools put everyone in the pipeline at the whims of the groups and individuals who produce the tools that lie upstream or downstream, depending on which direction you're looking at it. While proprietary development tools may help us, create more free software in the short term, the cost is unacceptable. It's unacceptable from a principled perspective. To compromise our commitment to freedom and openness in an attempt to achieve more freedom and openness is self-defeating, it's unstable, and it's ultimately unfair to our users and to the larger community that we're participating in. But it's also unacceptable from a practical perspective. It puts the benefits that our tools might achieve for ourselves and for others at the whim of third parties. It makes everything we might achieve contingent, at least to some degree, on something that we can't control. So what should we do? You won't be surprised to hear that I think that anyone developing free or open source software should ensure that their dependencies, either more to dependencies in the technical sense or just the tools that we rely on to get our work done, I think we should use them if and only if they are free. For example, we should use and support free alternatives to proprietary systems. We should use GitLab instead of GitHub. And of course, I understand that these tools are not always as good as proprietary alternatives. I actually have a whole other talk called When Free Software Isn't Better. And I'm not going to give that talk right now, but I can give you a short preview of the very, very end of it, the punchline, where I suggest two things. I suggest three things. Basically, that we should fight for, improve, and create free tools. First, we should convince the people who create proprietary tools to release their stuff freely. It's in their interest to do so. An addendum to the very first, to the BitKeeper story is that 2 years ago, 2016, Larry McVoy released BitKeeper under the Apache license, right? But by then, it was way too late. Git, the tool which was developed to create an alternative to his proprietary tool, already owned the market. Two, when the free and open tools aren't better, we should take advantage of our freedom to fix it. That means making our stuff easier, not just more featureful. And I understand that it costs time and money, but we need to spend that. We need to make that investment. And third, where the tools don't exist, we need to invest heavily in the development of new tools to help us build free and open source software more effectively and more efficiently. The Linux Foundation does a lot of this. For example, the Ford Foundation is right now actively supporting a bunch of innovative research and experimentation in this area. We need much more of this. The first thing that the sort of early GNU hackers did in the mid-1980s when they set out to build a free operating system, the system that, of course, became GNU Linux and which now runs on all of our servers, many of our laptops, and has parts in many of our phones and embedded systems and cars and televisions. The first thing they did was they focused on creating free tools for creating free software. For example, they created a C library, the project that became glibc, and they created a C compiler, the project that became GCC. And you know more than I do that the world has changed and that software development looks very different today than it did in the 1980s. But what this means is that, once again, we need to work to ensure that we can produce software freely using unambiguously free tools. glibc and GCC are not cutting it anymore. Our failure to do so is resulting in software that is indirectly much less free and much less open than its licenses might suggest. The movements for free software and for openness more broadly have not achieved success by compromising our principles. We will not be well served technically, pragmatically, or ethically by compromising the freedom of the tools that we use to build the free and open world. That's what I prepared. Thanks for having me.
Cool. Thank you. Thank you very much. You can catch him speaking next at the GitHub Universe conference later this year. I'm teasing. No, I think that is it's a really important message, and I think it's a great way to go spend our next couple of days collaborating on the kinds of open tools that we should be using in our development processes to build free software, and the kinds of things that we should be thinking about. So just a couple of housekeeping announcements before we get the rest of the conference underway. So I mentioned that there are presentations in this room, and if you go out and walk around the corner, that's where the collaborative sessions and the workshops are. For those collaborative sessions, each of them has a moderator. The moderator will probably ask for some help in taking notes on an Etherpad, which is this kind of collaborative editing document. How many of you have used Etherpad before? Great. OK. So don't have to explain that. But make sure, if you're in a room and people need help taking notes, pitch in on that. It's really important for us to all be able to share the information that we gather. Lunch is available on this floor, so if you want to stay up here and keep the conversation going, you don't have to leave. If you want to wander down to the first floor, there's a ballroom down there where there's also other lunch options as well if you need a break and want to take a walk. And this evening on this floor, we'll be doing a happy hour. So that's a good time to continue the discussions and over beers. And then tomorrow afternoon, we'll be doing a joint session at the end of the day back in here where we'll be kind of going over some of the conclusions and the topics that came up and thinking about what are the next steps that we want to go take into different communities and work on together. And after that, Mirantis and Netflix and Google are sponsoring a rap party, which is like wrapping a package, not hip hop rap. You don't have to prepare lyrics or anything. But that is just across the way at the Pan Pacific Hotel, and so lots of food and beverage and social time over there. So thanks for coming. I want to say also thanks to Claire Massey and Ashley Ferguson, who did most of the work to organize this and put it together. And thanks, yes. And thanks to all the moderators who are going to keep the discussion going. All right, that's it.